Hello students, I hope you are safe with your family. Once again welcome back to Ravi Sarji Mathematics, the easiest and finest way to learn the concept of mathematics. Students, today here we are going to study about the matrix. Generally, matrix has a vast use in the field of science. Matrix is used generally in physics. Matrix is used in data storage, graphical and computer programming. If you go in the deep to matrix, you will get surprised how matrix is useful in our day-to-day life. Students, here we are going to study few concepts about matrix. Students, you know what is matrix? You should know what is matrix. Students, matrix is a rectangular arrangements of number in column and row format. Once again, matrix is a arrangements of numbers in column and row format. Let us see the example over here. Suppose a matrix A is equal to, can be written as A11, A12, A13, A21, A22, A23, A31, A33, A32, A33. Students, here you can see that these are the arrangements of numbers in column and row format. Here you can see that A11 represents that the element of first row and first column. Element A12 represents what? This is element of first row and second column. Similarly, A33 represents what? Element of third row and third column. Okay students, I hope you have understood what is matrix. Matrix is the arrangements of numbers in a rectangular format. Let us see few types of matrix over here. The first type is row matrix. Students, row matrix means a matrix having one row. A matrix having one row is known as row matrix. Let us see with example. A matrix having one row. Students, a matrix having one row is known as row matrix. Suppose A11, A12, A13. Students, this is the example of row matrix because only one row is over here and 1, 2, 3 column. Okay, so generally the row matrix dimension is what? 1 cross n. 1 is what? The numbers of rows, and n is what? The numbers of column. Similarly, we can take another example over here. 1, 2. Let us see the another example over here. B is a matrix with row A, B, C. Students, here you can see that the dimension of this matrix is 1 by 4 and the dimension of this matrix is 1 by 3. Similarly, we can consider another example over here. C, P, Q. So dimension of this matrix is 1 cross 2. Next is column matrix. Column matrix means, students, a matrix having only one column. A matrix having only one column is known as column matrix. Student, Here we can get the example of column matrix like that way: A1 1, A2 1, A3 1, A4 1. So students, here you can see that in column matrix there is only one column and more than one rows. So students, here you can see that the dimension of this matrix is 1 2 3 4, means there are 4 rows and one column. Let us see the example. Suppose a matrix A 1 2 3. So students, here you can see that this matrix having 1 2 3 rows and one column. So dimension of this matrix is 3 by 1. Similarly, B, A, B, C and D. So dimension of this matrix is 4 by 1. Now the next matrix is zero matrix. Students, zero matrix means all the element of matrix will be 0. Once again, all the element of matrix will be 0. A matrix having all the element is 0 is known as zero matrix. A matrix having all the element are 0 is known as zero matrix. You can consider the example over here. Suppose A 0 0 0, all the elements will be 0 over here. This is what? Zero matrix. Another example, B 0 0 0 and 0, right? Another example, C 0 0 0 0 0 0. Students, all these the examples of zero matrix. Next is square matrix. Square matrix means the dimension of the matrix will be equal, means the number of row and the number of column will be equal. In square matrix, number of row is equal to number of column. It means the dimension will be n cross n. Let us see an example. Suppose a matrix A11, A12, A21, A22. Another example, suppose B A11, A12, A13, A21, A22, A23, A31, A32, A33. Here you can see that in the first example there is numbers of rows is 2 and numbers of column is also 2. So this is 2 by 2 matrix, and here is this is 3 by 3 matrix. So this matrix is known as square matrix A. Suppose an example P over here, 1 2 3 4 5 6 7 8 9. So this matrix P is also a square matrix. Let us move to the another example, another definition, diagonal matrix. In diagonal matrix, in a square matrix, all the elements excepting the diagonal will be 0. In diagonal matrix is a square matrix in which all the element excepting diagonal are always 0. So all the element excepting diagonal are 0. In this matrix, all the element excepting diagonal are always 0. So let us see an example. Suppose A an element, A 1 1 0 0 A 2 2, right? This is a diagonal matrix because here you can see that excepting the diagonal all the elements will be 0. See another example, B 1 2 3 1 0 0 0 2 0 0 0 3. Okay students, I think you have cleared that all the element excepting diagonals are 0 of this matrix. It means this is what a diagonal matrix. Scalar matrix. Scalar matrix is a kinds of diagonal matrix. In diagonal matrix, all the element will be same. Scalar matrix is just such a matrix. The diagonal elements are always same. Okay students, in scalar matrix, the diagonal elements are always same. Let us see with example. Suppose A and matrix 2 0 2. This is a scalar matrix. B 4 2 3 0 4 6 5 3 4. Here you can see that in the diagonals all the elements are same. So this matrix is what? A scalar matrix. Next is unit matrix. Unit matrix means students all the element in the diagonal is always 1. The element of the diagonal is always 1 and element of diagonals is always 1 and excepting all the element will be 0. So students, here you can write that diagonal elements are 1 and other elements are 0. In unit matrix, diagonal elements will be 1 and other elements will be 0. See with example. Suppose A 1 0 0 0 1 0 0 0 1. This is what? A unit matrix. Another example, A, otherwise B 1 0 0 1 0. This is also a unit matrix. Unit matrix generally represented by I. So in place of A and B you can write what? I. I means identity matrix. Next is upper triangular matrix. In upper triangular matrix, students, all the elements below the diagonal will be 0. Once again, in upper triangular matrix, all the elements below the diagonal will be 0. All the elements below the diagonal are 0. In upper triangular matrix, all the elements below the diagonal will be 0. See with the example. Suppose a matrix A having elements, suppose A, B, C, D, E, F, Z, H, I. But as per the definition, the element below the diagonal, the elements below the diagonal will be what? 0. So this is what upper triangular matrix. Let us see other example. B. Suppose elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. But as per the definition, the element below the diagonal will be 0. So these elements will be what? 0 and 0. Next is lower triangular matrix. In lower triangular matrix, students, all the element above the diagonal will be 0. All the element above the diagonal will be 0. In lower triangular matrix, all the element above the diagonal will be 0. Means suppose example A, B, C, D, E, F, G, H, I are all the elements of this matrix, but as per the definition, element above the diagonal means this element will be 0, this element will be 0 and this element will be 0. So this is what? Lower triangular matrix. Let us see other example. Suppose B, a number P, Q, R, S, T, U, V, W, X. So as per the definition, the element above the diagonal will be 0. So you can see that this is what? A lower triangular matrix. Next is comparable matrix. Two matrices are said to be comparable if they having same order. Same order means, students, the numbers of column and numbers of rows will be equal. Two matrices are said to be comparable if they have same order. Students, two matrices are said to be comparable matrix if they have same order. Let us see with the example. Suppose A as a matrix, elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, and another matrix B, A, B, C, D, E, F, G, H, I. So students, here you can see that this matrix A having order 3 by 3. 3 by 3, why is it so? Because there is 3 rows and 3 columns. Similarly, in matrix B, its order is also 3 by 3 because it having same order as A. So matrix A and matrix B are said to be comparable matrix. And finally, let us move towards equality of matrix. Two matrices are said to be equality if two matrices are comparable. If two matrices are comparable, if two matrices are comparable, then those two matrices are said to be equality of matrix. Suppose an example A, 1, 2, 3, 4, and another matrix P, Q, R, S. If these elements are comparable, so we can write what? P is equal to 1, Q is equal to 2, R is equal to 3, and S is equal to 4. Okay, students, here you can see that these two matrices are equality of matrix because their one elements are comparable. So these two matrices are said to be equality of matrix. I hope you have understood this topic. For more videos of this topic, don't forget to subscribe my channel Ravi Sarji Maths. the easiest and finest way to learn the concept of mathematics. Once again, if you have not subscribed my channel, just subscribe right now and don't forget to press the bell icon for further notification. Thank you students, thank you very much. Bye bye.